will create a project to detect the center point of a step. For example, we want to detect the center point of the circle, blue circle, for example. Firstly, create a new file in SRC folder. This is a 3D file target point. And then in the select list, remember add new target. We have the name 3D file subpoint, link to the file, and add the libraries here. And go back. I copied on the code from the 3D semantic 3D SMT camera CPP to this file, and we add some program. So firstly, look at this, how we detect the center point. Firstly, we will create semantic point cloud of the set point. For example, if we want to show only the blue circle set, so we just select the blue circle set to create the point cloud. It means in that point cloud there is only blue circle set, maybe has a one blue circle set or two or three, but no green circle, no green rectangle, no blue rectangle. Yeah. And then we will separate each in and put into a list. For example, if we have a two blue circle, we have two items. First blue circle, the second blue circle. And then we will get the center point of the first and the second blue circle. It is our algorithm. Firstly, we still create the semantic point cloud like we did in previous example, right? Okay, please look back here. Oh, I will have to upload again. Subtopic. There are some mistake about transfer to RGB to PGR, RGB to PGR. There's some mistake, and I want to tell again. In the combat get image, I will not use the command change PGR to RGB. I run it because the image is good, so I did not change. I will upload this code and go back here. In the create in the contact, after you receive the semantic image, you can create semantic point cloud, okay, and then you show to the point cloud viewer. That's good. And then the new thing is here. We will only create a tile point cloud. So how can we do that? Firstly, I will define a struct that include 4 information. First is the ID. It represents the class ID when we use neural network to predict the step. Okay, and then the color, that we colorize the mask. Here we have a atom 0 is the main the background with black color, and then with blue circle is not the color blues, here is the purple, but it is the colorize function we use in here in colorize sweet pepper here. So we have to use the same color to extract the wanted sap, the desired sap. Okay, so each class have colors here, and when we want to select a class or we want to select specific objects, for example blue circle is number 1, blue rectangle is number 2, we will choosing the point have exact this color. That's why we have a function create type point color. We send here an index. It is the class. When we want to select the blue circle, we put here number 1. And after we create a point cloud and select the color, we will check if this point have the true color, like equal the colors of the object we want. We select the point by push it in the point cloud and then we return. If there is no object have the same color we want, it will have a return nothing. Okay, no point. That's why we can select a type of the sap. It's sap type. And after that we have that type of blue circle, and then I will show it to the viewer for we first to check, and then I want to find only the center points of the blue circle. I will call the function show the center point of blue circle here. So what is the definition of this function? Firstly, I have two lists or two vectors. It is the one first vector or first list is to store the list of the saps, and the second we store the list center point, and here I use the vector 3D of agent class agent namespace. It stores 3D values in tuple, and agent will provide us the library to calculate between matrix and matrix, so it is easy for us to calculate in the future. Go back here. Where? Up. Sorry, I want to go back to the file center bar here. Okay, and then solve the center bar here. And then before we doing something, I want to clear to make sure that the list of the point cloud and the list of the center point is empty. And then I call the count group function. This group function, this function will separate the big point cloud into different smaller point cloud, and each small point cloud is a sap. And if we have two blue circle, it means that we have two small point cloud, and each small point cloud is a blue circle. It is a complicated function. we will separate them into each group depends on the radius distance. If a point have a distance greater than this radius, it means it's not in the group. So I give here the distance is 0.004. Although our resolution is 0001, but I want to make sure that I didn't miss any point, so I make it greater. This is a function like finding a close point. It is the main idea is that I will get the point and then I will find the closest point to that first point, and I put them into the list, and then I remove the found point in the original point cloud, and then I will get one by one in that list. I will find the closed point again, and I make a loop like that until the original point cloud is empty. I will get the group. It has wait a minute, I will review a diagram. Here I show you the algorithm how we separate each group. Firstly, I select a random point, and then I will put it in the group, and then I create and put in the group, and then I find all the points relate like close to that point, and I put that in a stack, and then I remove the point I find in the first here in the original point cloud, and then I will get one by one in the stack, and I continue to, and I go back to find the I will find the close points again, and I put in the stack like this. Okay, put in the I will find and again firstly find a random point, and then I create a group, and then I put the first point in that group, and I find all the close points to the first point that, and I put them into the stack, and I remove the first point from the original point cloud, and I check here if the stack size is greater than 0. It means the stack is not empty. I will get one point in the stack, and I put that into the group. I already create the first, and then I continue to find the closer point and remove the point I have used to first to find the other, and I continue to do that until the stack is empty. It means I have create one group, and I go back here to select a random point. If the original point cloud still have points, it means you have another group. If it is 0, if it is empty, it means no group, and we quit the program. That is the idea, and this is the function. It's a little bit big, and you should have the idea and read this function in your program clearly to understand. And after run this function, every time I find a group, I put in list point cloud here. List point cloud is the group, I mean in the diagram. And after we finish that function, okay, after we finish that function is the count group. Here we have a list of point cloud in list species here. And next I will find and next for each group in the list point cloud, I will find the center point, and the PC color center is the point cloud that I want to get to show in the point cloud viewer for us to see what we have done is good or not. So the PC point color will get on the data of the list point and also the center points here, because we have a list C push back the C is the the PC color center point will push back the center point to demonstrate. And go back here, we will read each item of the list point cloud list PC and find the center point. Find the center point is the simple function. It will calculate the average point of on point of a point cloud. Okay, and it will return back for us a point which have a 3 value x, y, and z, and we push in the list center point. We want to use to save the center point in the list, because later we will send this data to robot to ask the robot to move to that point. That's why we save them in the list. And the center point, because I want us to see like easier, so that I will add each value have a bigger position. It means I add here 8 point crater according to each x, y, and z. So that is the function. I will run the demonstration for us. Before that, I will run CAD-KeyMake. Okay, we run. Firstly, I will launch the camera. The service I already run here, and I will run the our nodes, 3D file step nodes, and we will have the point cloud here, the semantic image here. Sorry. Okay. So we have this is the true field. Okay. And now I will first click to show only blue circle. Right. First click only to show the blue circle. It is only blue circle for us. And then the second click is to find the center point and show the center point. You see here, this is the center point, have the white color. Okay, that's is our example. Okay, if we want to select on the center points, not only the the blue circle, we can pass here. Yeah, not a blue circle, but pass on the point cloud is the PT, right? You change this to PT and here show the center point of this PT. You will show on the point cloud on the type accept. I will run again. Pause. So try again. This is the semantic image. This is the point cloud. You want to do the yes. First is the circle, and then we show on the center point of the on set here. This is the center point. Okay, so that's on for our example. Next, we will learn how to control to connect to the UR robot, and we will learn how to move the robot to center point. Thank you.